good starting point for understanding soils is understanding how they form and how they develop. So we need to understand what the factors are that contribute to the formation of soils and the processes that go on within the soils that allow them to develop. I've come to the Lake District in the northwest of England to learn about how soils form. Phil Haygarth is Professor of Soil and Water Science at Lancaster University. Phil, what are the main factors that cause soil to form?
Well, when I teach soil formation, there is a really simple formula which we can use to describe that. That formula was derived from a very famous forerunner of soil science called Hans Jenny. And Hans Jenny described soil formation in terms of a very simple formula. And that simple formula, I tell all my students, is CLORPT. And that's a very simple way of remembering it, CLORPT. And that basically is 5 soil forming factors: climate, organisms, relief, parent material, and time. And if you think of that as 5 soil forming factors, CLORPT, that's a really great way to remember it. And that's how I'm going to explain it to you now.
Okay, so the first of those factors was climate. How's climate important?
Well, climate is important if you think of it in terms of extremes. Wherever you are in the world, it's the extremes of climate which generate the weathering of the basic parent material which form the soil. So, firstly, let's think of the extremes of rainfall. Very high rainfall or very dry rainfall promotes very different conditions. So in one extreme, you've got deserts, and the other extreme, you've got the tropics. So high or low rainfall, extremes of rainfall are very important. Second part of climate would be the extremes of temperature. So it's like freezing and thawing, or heating and drying. They're all very important at promoting the weathering of the soil and the weathering of the rock and the material which goes towards forming the soil. And thirdly, you can think of the wind actually plays a very important role in some places too, in terms of eroding material and eroding the rocks. So it's the extremes of climate which all play that role in soil weathering, which is part of that climate role.
Okay, so that's all the processes that make the rocks into smaller particles and turn them into soil.
Yeah.
What about organisms? How do they play a role?
Organisms are critical. They're the living part of the soil. Okay, so the obvious one is plants. Okay, so here we are on this mountain hillside. We've got a bit of some grassland here. Plants, as we all know, they grow in soil. What do plants do when they grow in soil? They put roots down, and when those roots penetrate into the soil, they help the weathering process. They help break the soil up, and they also move nutrients and chemicals around into the soil.
That's plants. What about animals?
Yeah, animals also. Now, animals are really interesting because you've got a whole spectrum of animals. You know, we've got moles, we've got sort of we call them macrofauna. You know, all these things that burrow into the soil, they all play a role in digging it out, in creating that weathering, that erosion process, and in creating ultimately the structure, really. So we've got large animals that burrow around in the soil, but then we also have smaller animals too. The classic one is the earthworm. The classic earthworm plays a really key role in turning over the soil and forming it, and ingesting it, excreting it, and moving all the soil particles around. But then also we go to much finer scale organisms, small bacteria, small fungi, really microscopic creatures, and they play a huge role in turning over all the biological activity in the soil. So soil organisms, from a range of sizes, both plants and animals, absolutely critical to soil formation.
So, climate, organisms, relief, that's next. What do you mean by relief?
Yeah, relief's an interesting one. Well, the other word that people often use for relief is topography. It's the actual shape of the landscape. And here we are in this beautiful mountain landscape. We don't get a better example of extremes of topography or extremes of relief. The shape of the landscape, be it on a steep hill like we have down here,
yeah,
or a mountain top or a valley bottom, are all critical to playing a role for how the soil is formed. If the soil is on a steep slope, the soil is very thin, it's unable to form because of gravity, because of the shape of the slope, and because of the way water drains across it.
Well, we're on a steep slope at the moment. Let's see if that works.
So if you have a look at this slope here we are, this mountain face, all this rock, all this scree slope, you can almost imagine the soils are going to be thin because it's just covered in rock.
Okay, well let's test your theory. And well, straight away I'm hitting rock, so I've got just a few centimetres of soil, so yeah, very shallow. So now if we go down the bottom of the slope we should have a much deeper soil.
I think we will do. Let's go and have a look. Here we are, we've come down from the hillside and we're now in the valley bottom. I would wager that this is going to be a much deeper soil here in the valley bottom, so let's see if I'm right.
Oh yeah, definitely a deep soil there.
Yeah, so the spade's gone really deeply in and there seems to be lots more there because we're in the valley bottom now. Now we're still in a mountain environment of course, and I would wager if we went on down into the valley beyond, right down into the agricultural area, we'd get even much deeper soils. But the point is, relief topography makes a real difference on soil formation.
So, next on the list, after relief, is parent material. And that's the rocks that the soil forms from, isn't it?
Absolutely. Think of parent material as the core ingredients of the soil. It's the raw mineral stuff which the soil is formed from. And here in this mountainside we can see some volcanic hard rock here, which is the essence, the basic parent material for the soils that are forming around here. And that's, if you like, the classic really is soil is formed from rock. But also I want to emphasise that parent material can take different types of forms which might not be as obvious. Parent materials can also be formed from glacial deposits, from glacial tills or glacial outwash material which can form as a result of past glacials. So parent material in some circumstances could be boulder clay or amalgam of different composite materials. Another thing to bear in mind is that rivers and estuaries can also deposit silt and sediment, which also constitutes at sometimes the parent material for a soil to form.
There'll be other contrasting rock types that will lead to very different conditions.
So if you take, for example, a limestone is very calcareous, it has completely different chemical properties, and that really has a very different effect on the soils that are formed in calcareous conditions to soils on these types of rocks in these environments, which will be probably more acid. So it has effects on the chemistry as well.
So our final soil forming factor is time. How long does it take for a soil to form?
Well, as an interesting rule of thumb, it takes for 2 to 3 centimetres of soil takes about 500 years to form. So that reminds us how precious soil is and how we need to look after it because it takes so long.
These soils here that we're stood on, how long will they have taken to form?
Well, we can take a clue from landscape history. Here we are in a landscape which was formed in the last glaciation, which we know was about 10,000 years ago here. So these soils around here are about 10,000 years old. In other parts of the globe where we know landscape history is different, for example the geological history might be different, some soils can be up to millions of years old. And an interesting fact is, of course, now with increased human and anthropogenic activity, humans also interfere with the soil by coming along and doing stuff, which leaves an interesting final point for reflection. Some people have suggested there's a 6th soil forming factor, and that is human beings.
So that was our 5 soil forming factors. Next we're going to look inside the soil.